All right, honors geometry. Today is Thursday, April 18th. You guys are going to be watching this video to take notes on 11.5 volumes of pyramids and cones. You'll work on the homework after that. The homework key should post after school, so work on the homework now. Finish it, hopefully, try all the problems, and then check the homework key to help you kind of get combobulated on that. So 11.5 volumes of pyramids and cones. We talked about volumes of prisms and cylinders yesterday. Theorem 11.8 on your notes says the volume of a pyramid is 1/3 the product of the area of the base, and the height of the pyramid. Okay, so the volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. Okay, this GIF didn't come through all the way, unfortunately. But kind of what the GIF shows is that you can fit three pyramids. Let me see if I can draw this at all. You can fit three pyramids inside of our shape here. You can fit three pyramids inside of that prism with the same base. Okay, so a prism, that's volume BH, B being the area of the base. So in the case of a pyramid is like 1/3 of that. So the prism with the same size base as the pyramid would be 3 times the size, or a pyramid and a prism with the same size base, the pyramid would be 1/3 of the size. Okay. Once you're done watching this lesson, I would recommend next going down to the link below and watching the demonstration of pyramid volume video I also posted, where I fill those geosolids I've been showing in class up with water, and then kind of show you what that looks like when we're filling it up, kind of a visual representation or demonstration of this right here, this theorem. Okay, that's theorem 11.8. So if I'm trying to find the volume of this thing, I'm going to need to use 1/3 area of the base times my height. My height is just the distance from the vertex to the center, or to vertex, and then that's going to be perpendicular, I should say, perpendicular to our base. So that's going to be 6. That's my height. Area of the base is just 8 times 7. Okay. So my volume there would be 168 inches cubed, I believe. 56 times 3, yeah, 168 inches cubed for that volume. Pretty straightforward, pretty easy. Just finding the area of that guy times 1/3 times that height. This one, similar idea. This time they gave us the slant height, and they gave us that it's a square pyramid. We name pyramids by their bases. So I'll write my volume formula. You're being graced by the background of these slides being Monet's water lily. Again, I said I went through that period of really liking to put famous artwork behind some of my slides. Anyways, if I'm trying to find that height, I first need to determine that this length right there, from the edge to the center there, is 6. Okay, so in a square that's going to be true. That's 6 centimeters. Okay, and I know that the hypotenuse is 10, so I can use Pythagorean theorem. 10 squared is equal to 6 squared plus h squared. That's 100, 36, and h squared. Really, we're going to subtract our 36 on both sides. Get 64. So what squared is 64? 8. 8 squared is 64. So my height is going to be 8. I know that. And the area of my base is going to be 12 by 12. That's 144. It's a square. You just multiply one side by the other side, but all the sides are the same. Okay, remember when I said 3, 4, 5 right triangles come up all the time? 6, 8, 10. If you divide each of those by 2, it's really just a 3, 4, 5 right triangle. It's got that same ratio of sides. Anyways, back to our 1/3, excuse me. 1/3 times 144 times 8 gives me 384 centimeters cubed. Again, remember, when I'm working with volume, I got to have a cubed units, because I'm in 3 dimensions: length, width, height, 3 dimensions. What about this one? It says a tea infuser in the shape of a right rectangular pyramid. So I'd have a right rectangle, excuse me. Rectangular, not right triangular. Right rectangular pyramid I guess that's kind of a, don't have to say right rectangular, but rectangular pyramid, it's a T infuser, is 7.9 centimeters tall. So right there, that's 7.9. That's not really a good dotted line. 7.9 centimeters tall. Has a base that is 3 by 1.5. And to make the best tea, the infuser should be 80% filled. So let's find the volume of the entire infuser, and then we'll work with that 80% here in a second. So I'll go 1/3 times the area of the base, that's 3 times 1.5. I'll multiply that by 7.9. Oops. Yep, there we go. Gives me 11.85 is the volume of the entire diffuser. And how do I find 80% of that? Think about that for a second. 80%. I gotta multiply by 0.8. So if I multiply by 0.8, that's 80%. So I'll take that and multiply by 0.8. I need 9.48 cubic centimeters of tea, which is a very scientific sounding thing. I don't think you'd ever measure out 9.48 cubic centimeters of tea to pour inside of something. But yeah, that's the tea leaves. You need 9.48 cubic centimeters of tea leaves in that infuser. Moving on to cones. The volume of a cone is 1/3 the product of the area of the base and the height of the cone. Like we've been talking the last couple weeks, cones and pyramids kind of follow, or I should say cones and cylinders kind of follow after prisms and pyramids in that they have the same sort of relationship. So instead of perimeter and surface area, we use circumference when we're finding the lateral area. In the same way, a cone is also going to be 1/3 the product of the area of the base and the height of the cone. So a cone is really 1/3 of the volume of a cylinder with the same base. 1/3 of the volume of, so if you have a cylinder also with a base of the same size, so all the pi r squared would be the same, and the same height, then I would have 1/3 of that is the volume of the corresponding cone. Here's an example you can look at. I'll pause here if you want to pause the video and look at that example. The radius of the base of the cone is 6. Really, it's like 1/3 base times height here. 1/3 times the base, that's just a circle times the height. The height, again, is that segment going from the vertex perpendicular to the base. Let's try this one. So we have 1/3 pi radius squared, radius is 5, times the height of 9, right? So filling in all my pieces, that's going to be 1/3 of 25 pi times 9. That 9 and that 1/3 become a 3. 3 times 25 pi is 75 pi. So if I ask for it in terms of pi, you just write 75 pi, or 235.6 inches cubed. Cubic inches would be your nearest tenth. All right. What about this one? How do we find the radius, right? Working through this, if I'm still going to find the volume eventually, so I'm going to need 1/3 pi r squared times the height, right? And I know the height is 8. But how do I find that radius? How do I find that radius? I'm going to have to square something and then multiply it by 8 and pi. Well, again, anytime I have a right triangle and 2 sides and 1 missing side, I'm going to want to use Pythagorean theorem. So I'm going to have 8 squared plus x. We'll call it x. Well, we'll call it r since it's a radius. R squared equals 10 squared. Anybody see a pattern? We said 6, 8, 10 became 3, 4, 5. So what do you think r is? R is indeed going to be 6, because that's true, right? 64 plus 36 is 100. Perfect. So if you know your 3, 4, 5s and you can recognize them, you can save yourself some time, which I love to do. 1/3 of 36 pi times 8. So 1/3 of 36 is going to be 12 pi times 8 is 96 pi. Or, what is that in let's see, or 301.6 meters cubed. Cubic meters of volume inside that cone right there. Cubic meters of volume. 300 cubic meters. Again, 1 cubic meter of liquid would be, a meter by a meter box, a meter by a meter by a meter box filled with water, right? Or any liquid. So we have a 30-yard tall conical storage building. I already got my height drawn in there for myself. 30-yard tall conical storage building that can hold 45,000 yards cubed of sand. Yards cubed tells me this is a volume, okay? It has 2 doors. There they are, exactly opposite each other. If you're walking along the perimeter of the building, what's the distance you'd walk between the doors? So really, I'm not looking for the radius or the diameter. I'm looking for the circumference, but not the whole circumference. I'm going to be looking for half of the circumference, right? 2 pi r, half of 2 pi r. So, but in order to do that, the only variable I have is radius. Let's go ahead and set this one up. Since this is, well, actually, I'll stop here, and if you guys want to solve this yourself, you can pause here and try and solve it yourself first. All right, so if I know the volume is 45,000, then I can set up my volume equation from there, right? It's going to be 1/3 times pi r squared times the height, which we said was 30, right? Using this, I have a 1 variable equation, which is wonderful. I'm going to take my 45,000 and multiply him by 3, which is getting rid of that 1/3, which is 135,000. Pi r squared 30. And then I'm going to take that and divide by 30 on both sides. And I get 4,500 equals pi r squared. And divide by pi. Divide by pi. And I get 1,432.4-ish. I rounded that. I didn't round on my calculator, though. I'm leaving the number in my calculator. And then I'm going to take the square root of that number I still have in my calculator. And that gives me 37.8 equals my radius. Just found the radius. Once I found that, I'm not going to delete that number from my calculator. I just rounded it to show my work. But I'm going to go ahead and find 1/2 of 2 pi r. Whenever we have 1/2 and 2, we can cancel those. That's going to be my distance. So pi times that 37.8 number I kept in my calculator. So I'm going to click times pi and get 118.9. That's the distance between the 2 doors if I was walking around the building. Let's go with that in yards, 118.9 yards. I thought that was kind of a fun problem, so I wanted to include it. And it uses our volume of a cone knowledge. Last thing before homework, what is a frustum? A frustum is the portion of a cone or pyramid which remains after its upper part has been cut off by a plane parallel to its base, or which is intercepted between 2 such planes. So if this whole thing is a cone put together, then when I cut off the top part, then I'm left with just this bottom part, which we call the frustum. Okay. I'm not going to necessarily test you for regular credit on any of the assessments, hint, hint. But yeah, you should maybe know what a frustum is if you want to maybe receive some additional points. We'll call them that. What about finding the formula? How do I find the volume of a frustum? Well, that's a great question. The volume of a frustum is going to be what? Well, if I'm taking a look at this, it's going to be the volume of the cone, the whole cone, minus the volume of this mini cone right there. That's our mini cone. Here's the whole cone. Okay, so I'm going to take the whole cone minus mini cone, whole cone minus mini cone gives me frustum. So whole cone minus mini cone gives me frustum. Okay, so whole cone would be 1/3 times pi, the radius is big R squared, times the height big H, minus 1/3 times pi times the small r, radius right there, squared times small h. That's all you're going to do to find the formula, okay, or to find the frustum. Really, you don't have to remember that. You just have to remember how to find the whole cone and the mini cone, identify those parts, and subtract to find the volume of your frustum. Let's do an example really fast. Let's find the volume of this frustum. So if I'm given a couple things here, right? I know the volume of the frustum is going to be the volume of the whole cone. So let's find him. Volume of the whole cone minus the volume of the mini cone. So the volume of the whole cone is going to be 1/3 times pi. Radius here is 10. Pi 10 squared times the height, which is going to be 28 plus 17, right? So 28 plus 17. That's my height of the entire cone, minus 1/3, this is for the mini cone, times the pi 6 is my radius right there, pi 6 squared times my height of 28. Okay, this is going to give me the volume of my frustum. Let's go ahead and multiply some stuff out. I got 1/3 times 100 pi times 28 plus 17. I think that's like, what, 45? Seems like 45. I got 4,712. Hope I typed that in right. 0.4. I'm just rounding that. Not in my calculator, just in my work. Minus, I got 1/3 times 36 pi this time, times 28. Gives me 1,055.6 rounded. When I subtract those two numbers, I'll just, since I have a TI 84 Plus Silver Edition, I'll just go up, click up, and find those numbers, input them again. The volume of my frustum is 3,656.8 centimeters cubed. There you go, that's the volume of your frustum. My picture is probably not drawn to scale, but because that doesn't look like that would be that much more. But I guess this gets pretty skinny at the top. So that's your 3,656.8 centimeter cube frustum. That's how you do it. Here's your homework. Good luck, everybody, on the homework quiz tomorrow. If you have any questions, please email me. I will try and respond. See ya.